Hello friends, this video on structure of atoms part 36 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 35. Obviously, there are exceptions in the electronic configuration. So if you see copper and chromium, they have 5 and 10 electrons in 3d orbitals rather than 4 and 9. I'll tell you, let me draw the copper and chromium electronic configuration else you understand this. So chromium has number of electrons 24 and copper has 29. Let me write the order of increasing energy first. So first I'll get 1s, then I'll get 2s, then I'll get 2p, then 3s, then I'll get 3p, then I'll get 4s, and then I'll get 3d. Correct? That's how it is. If you want, I can write also, I can for you 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, like this. So 1s you get, then you get 2s, then you get 2p here, then you get 3s here, then you get 3p here, then you get 4s, and then 3d. This is the order of increasing order energy I have. Right? So it has 24. So I'm writing for chromium now. 24. So let me draw this orbitals first. 1s, then I have 2s, then I have 2p, little bigger, 2p, then I have 3s, then I have 3p, then I have 4s, and then I have 3d. D will have 5. 1, 2, 3, 5 orbitals. This is the order of increasing order of subcells. 24, first will come here, second, third is easy, fourth is easy, fifth, sixth, seventh, eighth, ninth, 10th. This I think we have done for neon. Similar thing. Then 11th, then 12th will come here, then 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. This should be the configuration according to our rule, right? We have told that the cells get first one electron, then it gets paired up. This should be the electronic configuration. But in case of chromium, if you see, if you just transfer one electron from here to here, right, what happens is 4s becomes half filled and 3d also become half filled, right? Both are half filled, and I told that half fill provides extra stability. So this guy will go from here and will come here. This provides extra stability to the chromium. This is a special electronic configuration. This happens in few other cases also, where due to provide extra stability, this electron moves from here to here. We can take the same example of copper also. Let's see copper. Copper has 29. So let's write for copper. Same will write. We have 1s, 2s, 2p, 3s, then I have 3p, then I have 4s, then I have 3d, right? And this p will have 3 orbitals, 1, 2, 3, 4, 5, this one, right? So let's take for copper, this is 29. So 1 comes here, 2, 3, 4, 5, 6, 7, pairing start, 8, 9, 10, 11, pairing 12, 13, 14, 15, again pairing start, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29. So if you see, this guy is not even half filled, not even full filled. So this guy here also will, again, electron will jump from here to here. So with that, this becomes full filled and this becomes half filled. Correct? So with this also, this is half filled and this is full filled. So this also provides extra stability. So the electron will move. So this is a special case that happens. The electron moves just to provide extra stability. Correct? This is just to provide extra stability. Now the question is how we came to know that copper or chromium has this electronic configuration, right? Nobody, I mean, there's somebody would have seen this copper has this electronic configuration really, and chromium has this electronic configuration. Yes, this is determined by spectroscopic method. Using very highly magnified lens, they actually see the atoms, and scientists are able to see the electrons inside this, the distribution of electrons inside this, and they found that for copper and chromium and some other places, just to provide the extra stability, the electrons shuffle from one orbital to another orbital. Now we have learned electronic configuration. The question can be, what is the use of electronic configuration? Why are we spending so much time on this to understand the electronic configuration? So the usage of chemical electronic configuration is to because understand the chemical behavior of an element. So it tells why some elements are metal, why others are non-metal. These things are explained by the electronic configuration. It also explains why some elements like helium are not active, but halogens like chlorine are reactive. So these things in the next chapter we'll learn about the different, we'll again learn the periodic classification of elements and the behaviors of the elements, and the behavior is dependent on electronic configuration. That's what we're learning in the next chapter. But just understand that it is electronic configuration which decides the chemical behavior of a element. And please note, these questions were not answered by the Daltonian model. In Dalton was not able to explain why some elements are reactive and some elements are not reactive. And this is explained using electronic configuration. So we have told that half-filled subshells provides extra stability. What are the reasons? The first reason is the symmetrical distribution of electrons, which provides extra stability. Second is the relative small shielding that happens because of half-filled subshells, smaller Coulombic repulsion energy, and the large exchange. These are the reasons for extra stability of half-filled subshells. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.